Let's solve this Olympiad equation together. It says x raised to power minus 1 is equal to 27 raised to power x. Let's solve this together. Now, to be able to solve this question, the first thing to do is that we can rewrite this by saying that a raised to power negative 1 is the same thing as 1 over a. Hence, x raised to power negative 1 become equal to 1 over x, and this is equal to 27 raised to power x. Let's raise both sides to the power of 1 over x. So we have 1 over x all raised to the power of 1 over x to be equal to 27 raised to the power x all raised to the power 1 over x. Okay? We now have 1 over x all raised to the power of 1 over x to be equal to, now 27 raised to power x all raised to power 1 over x follows from the rule that a raised to power m all raised to power n is equal to a raised to power m multiplied by n. Hence, this one will become equal to x times 1 over x, which is equal to 1. Hence, we have 27 left here. Okay? So we have 1 over x raised to power 1 over x to be equal to 27. Now, this gives us a bit of confusion because this is in the form of x raised to power x. Okay? And x raised to power x is the format of the Lambert's formula. But we're not going to use that today. Okay? Now, what we're simply going to do is I will just say, what are the multiples of 27? 27 can be rewritten to be equal to, so 27 now can be 3 multiplied by 3 multiplied by 3. That's 27. Now, 3 multiplied by 3 multiplied by 3 is also 3 raised to power 3. Okay? Hence, I have that 1 over x raised to the power of 1 over x is equal to 3 raised to the power of 3. Let's compare. Any place we have 1 over x, we have 3. Here we have 1 over x, we have 3. So it means that invariably that 1 over x is equal to 3. Hence, if we inverse, we take x to be equal to 1 over 3. And this is the answer to this question. Thanks for watching.